major part that I want to cover here is called domains. See, till now we have always been talking about domain of X and range for Y. So I have always been saying that, okay, if Y is a function of X, whatever values X will take, that is the domain. Whatever corresponding values Y will take, that is the range. But now I have Z as a function of X and Y. So whatever values X and Y will take, that will be the domain. Okay, let's take the first question. One thing is very clear to us: whatever comes inside the root has to be positive. So accordingly, I want my X minus 1 to be greater than equal to 0. So I want my X to be greater than equal to 1. And I want my Y to be greater than equal to 0. Suppose, let me just add one more part to the question. Suppose it says, determine the domain of this and graph the domain. Suppose you also have to plot what the domain will be. So in that case, I understand that this is my x-axis, y-axis. This is 1. X has to be anything greater than 1. Y has to be anything greater than 0. So this first quadrant right here, this becomes the domain of my function. Notice that now in domain, I am giving the entire set, right? By set, I mean, I'm giving you what values should X take. Also, I'm giving what values should Y take. So I'm giving you values for both X and Y. So I can say that the domain of this function is this. It's always in first quadrant, but X has to be greater than equal to 1 also. Now let's say the other part. So let's see the second part. It is given that g of xy is equal to 2 upon x square plus y square minus 4 under root plus 9 minus x square minus y square under root. I've just opened this bracket this here. Okay, let's see how to solve this. So what I'm going to do is the following. Very simple. Because this is coming in the denominator, it has to be greater than 0, strictly greater than 0. Denominator cannot be 0 and it cannot be less than 0 because it is under root. So I have x square minus y square, sorry, plus y square minus 4, strictly greater than 0. I have x square minus y square, sorry, plus y square, strictly greater than 4. This is condition 1 that has to be satisfied. Also, this is also coming under root. So whatever is under root has to be positive. So I also want that 9 minus x square minus y square is greater than equal to 0. Notice the difference. Here I will not have equal to sign because it's in the denominator. I can't afford to have denominator equal to 0. Numerator can be 0. If this part is 0, it works well for me. Then also I will get some answer for gx. So my numerator can be greater than or equal to 0 here. So based on that, I will get 9 greater than equal to x square plus y square. Now, let's hold for a second and let's think about what these equations really look like. So remember the equation of a circle. The equation of a circle was x minus a whole square plus y minus b whole square is equal to r square. So it was centered at a comma b, right? So anywhere wherever your a comma b will exist, that will become the center, and then you can draw a circle around it, right? Now if I go ahead and I take back my, I look back at my equation, this is greater than, I understand that, but had it been an equal to sign, then x square plus y square equal to 4 is nothing but x minus 0 whole square plus y minus 0 whole square is equal to 2 square. This looks familiar to equation of a circle, right? It's centered around origin, radius is 2. So what I go ahead and I do is I plot a circle with radius 2. Now, I have already taught you how to solve for inequalities. So first of all, you plot according to equality, and then instead of x and y, you put 0. So 0 square plus 0 square greater than 4. 0 greater than 4 is a false statement. So you are going to mark the region away from the origin. Also, because the circle represents equal to 4, circle is not included. So I will just kind of go ahead and make it dotted because circle is not included. Okay. Now let's go to the next part. The next part that I got for my domain is x square plus y square less than equal to 9. First, let's draw for equal to 9. So when I say x square plus y square is equal to 9, I can rewrite this as x minus 0 whole square plus y minus 0 whole square is equal to 3 square, right? And now I understand that radius is 3 and it's a circle. So now what I'm going to do is I'm going to just mark 3 here everywhere. And I'm going to just circle this around 3. Okay. And now I'm going to put, so what is my equation? My equation was x square plus y square. And it was less than equal to 9. So 0 plus 0 less than equal to 9. This is true. So I mark towards the origin. So what I'm going to do is I'm going to start highlighting this towards the origin, including that circle, okay? Because equal to is also true. Equal to line is included actually. Now if I ask you, what is the common region between the two? The common region is this part. Let's just highlight it with some darker color. This is my common region, right? Only this part. So this becomes the domain of this function. This is this shaded region. This is the domain. So how do I make the domain? If I have to graphically show it, I have a circle around 2, which is not included. I have a circle around 3, which is included. So this region between in this is my domain for which my function is defined. Okay. Not including this thing. This becomes the domain. So the domain, to kind of find the domain, the process remains the same. Nothing is changing there. You just have to find for what values of x and y the function is defined. Earlier, I was finding for what values of x is my function defined. Now I'm just saying for what values of x and y my function is defined.